Hey guys, here's one of the DOK3 problems from your limits page. So this is a two-part question. First, they want to give two values of A where the limit cannot be solved using direct evaluation. So that means what A values can we not just plug in order to find the limit? So remember, denominators cannot be equal to 0. So I know that if I plugged in a number here that would make this denominator equal to 0, it would make this an unsolvable limit. So what x value, if I plug directly in here, would make this equal to 0? Well, I know negative 2 plus x cannot equal 0. So if I add 2 to both sides, x cannot equal 2. So that's one A value, where if I tried to plug this straight in, I could not get a real answer. So now that's one fraction, but if we look, our denominator here is another fraction. So what x value could I not plug in here? Or if I tried to plug in here, it would make this whole denominator 0. Well, I look, this is 1/2. 1/2 plus what would equal 0? So if I plugged in, so 1/2, well, let's see, negative 2 plus x plus 1/2 cannot equal 0, right? This whole denominator cannot equal 0. So I have 1 over negative 2 plus x cannot equal negative 1/2. I just subtracted that to this side. So now I could cross multiply. 2 cannot equal negative 2. Oh, negative 1 multiplied by negative 2, which is 2, minus x. So notice I was distributing the negative 1 to both of those. So if I subtract 2, 0 cannot equal negative x, so x cannot equal 0. So the two A values that will either make this denominator equal 0 or this denominator equal 0 are A equal 2 and A equals 0. So part B is asking for one value of A where the limit can be solved using direct evaluation. Well, that's any A value where A does not equal 2 or A does not equal 0. So examples vary. It could be 3, 7, 9, 11, right? All of those numbers, we could plug them straight in and we would not get 0 in our denominator. So once again, this is for when this denominator cannot equal 0, and all of this work was for when this entire denominator could not equal 0.